Hello and welcome to week 4's lesson. Today we're going to talk about shielded metal arc welding of pipe. Chapters we covered before, the shielded metal arc welding of plate, pretty much everything we talked about then will apply here. Filler metal selection, best practice, all that stuff, but this week we're going to apply it to pipe. So stick welding has been done on pipe for probably 100 years, and in one way or another will be around for another 100 years. And why is that? Well, bunch of reasons. The big one being it can be done with really basic tools. You need a DC welder and a dirt hole in the ground to lay underneath the pipe, and you can weld pipe. It takes an incredible amount of skill to be able to do it consistently well, and that's why those people that are on the road doing that pipe work, they tend to make a lot more money than guys that work in shops. But the guys that work in shops aren't laying in dirt holes all that often, so it's kind of a trade-off. Well, there's a lot of other reasons why stick is still around, and the alternative to stick in a lot of cases is mechanical connections. So it's going to be threaded connections or stuff like that, and welded pipe is universally better than any kind of mechanical connection you can get. It's lighter weight, you don't have the extra weight of all those fittings, it's stronger, the welded joint is always stronger, there's lower maintenance, it's much less prone to leakage, it's better flowing, okay? And that's, I'll draw a diagram on the board, but that also plays right along with, let me get my pen, it also plays right along with less maintenance and longer lasting. So when we're looking at two pipes that come together, if I've got a mechanical fitting, I'm going to have a separation, that is totally not scale, I'm going to have a separation between these two. So I've got threads up here, threads down here. I've got this big coupler. All the threads together. That is the wrong side, Mike. There we go. Threads go on the outside of the pipe. So we've got this thread coupling in here, okay? As product, whatever it is, gas, liquid, whatever, moves through this pipe. When we have these gaps right here, as this product moves through this, it's going to get caught up here and it's going to create an eddy. They call it a cavitation. It'll come through here and it'll, like this, if our direction of flow is this way, it's going to come through here and then it's going to have to climb up out of that and flow out. So that's one of the reasons why welded pipe flows so much better. A welded pipe, got our weld joint. I'll just show one side of this, but we've got our weld joint. We want to run a root pass in. We get a nice root, get some nice fill passes, get a nice cap. Our obstruction in this pipe is very minimal. By code, this has to be 1/8 of an inch or less. So our obstruction inside the pipe is very minimal. Very little flow disruption. We can run into problems if our root has too much reinforcement. We'll have a problem with these cavitations that come around, but much less so than a mechanically connected pipe. And the problem with cavitation is it does really bad things inside the pipe. That swirling wall, you don't think about it, it creates a magnetic field, it creates static electricity is what it does, and it will slowly deplate the metal out of this pipe. So what you'll look at in 5, 10, 20 years, depending on the pipe, is, let me clean this up so we can see, is if our direction of flow is this way, you'll see these big pitted areas right here as this comes through, just like a river. You know, at the bottom of a waterfall, there's usually a huge hole. It does the same thing. It starts deplating this material and taking it out, and eventually that's going to fracture right there. If I've got too much reinforcement in the toe of a welded pipe joint, be it stick, TIG, whatever, it'll be the same issue. If, let's say, my root had too much reinforcement, it was really steep, I'd have the same thing. As flow comes through, it'll cavitate and it'll start to just eat away the base metal on the basic downwind side of the pipe joint, and eventually that's where the crack will be, and it always happens right next to the weld. So anyway, welded pipe has tons of applications, tons of advantages, and that's not going to change anytime soon. So this one, just like the previous weeks, will be a little bit different. We're going to give you this short little sheet or shielded metal arc welding introduction to pipe. And then we're going to have a much bigger pipe-specific module that we're going to present to you. That'll be down in the chapter below somewhere. So anyway, keep a lookout for that. So for the rest of the week, watch this video, watch that video, watch the PowerPoint, do the forum assignment, then do your homework at the end of the week, and that should be it. If you have any questions, find me online, find me in the lab. I'll answer them best I can. Thanks.